Okay, let's talk about note card 38. We're going to be simplifying, multiplying, and dividing rational expressions. So the basic thing we want to start with here is whatever you can factor, always factor. Let's look at the first example. So the first thing we want to do is see if the top and the bottom will factor. Well, the top factors, it's a difference of squares. I have x plus 4 times x minus 4. And then the bottom is very easy Mustang factoring. I don't even really have to go through all the steps of Mustang factoring. I'm looking for two numbers that add to 8 and multiply to 16. You should be able to see that that's x plus 4 and x plus 4, because 4 plus 4 is 8 and 4 times 4 is 16. If you can't see that, just take your time and do the Mustang factoring and you will get that. On this note card, if there's some trinomial factoring that's a little bit harder than that, I will work it all the way out. So now I get to this part. I have this is an equivalent to what we started with, but this is in factored form. And because I have multiplication, x plus 4 is being multiplied by times x minus 4 on top, and then x plus 4 is being multiplied to x plus 4 on bottom, I can cancel like terms. So I have an x plus 4 on top, I have an x plus 4 on bottom, and they cancel, and what I'm left with is x minus 4 over x plus 4. And that's all I do. There's nothing else to do there. I don't have to keep it in parentheses if I don't want. X minus 4 over x plus 4. Nothing else to be factored on top or bottom. Nothing else can be canceled out. So this would be my answer. Pretty straightforward and simple, I hope. Let's look at the second problem. The second problem, we're not just simplifying. If we go back really quick to number 1, we were only simplifying the top and the bottom. What I have for number 2 is I have this fraction being multiplied with this fraction, but I still want to approach it the same way. I want to look at both of these fractions and factor the top and the bottom if I can. The top of the first fraction, I can factor out a common term, 3. If I pull out a 3, I'm left with x minus 2 over 5x times the top over here. I can factor. Let's just look at that Mustang factoring there. I have A is 1, B is negative 1, and C is negative 6. My signs are going to be different. The biggest one will be minus or negative. A times C is negative 6, but I'm not worried about the negative sign because my signs are taken care of up here. Look at the factors of 6. I have 6 times 1 and 3 times 2. And my signs are going to be different. The biggest one is negative. So which two add to negative 1? The B term there. And that's these two. Negative 3 plus 2 adds to negative 1. My next step is to divide by A, which is 1. Reduce if I can. They cannot reduce. So I have for the top here x minus 3 and x plus 2 over, this is difference of squares, the denominator of my second fraction. I have x minus 2 and I have x plus 2, and so I look to see what cancels. Because I have multiplication on top and on bottom, this expression times this expression and this expression times this expression, the 2x plus 2's cancel. And what I'm left with here so far is, going back to here, I have 3 times x minus 2 over 5x times x minus 3 over x minus 2. Okay, Now another property with multiplying fractions is we can cross reduce or cross simplify. In other words, if I have something on top that matches something on bottom, I can cancel those two terms. Likewise, if I have something on bottom over here that matches something top over here, I can cancel those two terms. Well, hopefully you can see that this x minus 2 and this x minus 2 cancel out. And when I'm multiplying fractions, I multiply top times top and bottom times bottom. So what I have left is 3 times x minus 3. The two tops multiply together. And the only thing that I'm left with on bottom is 5x. And I'm almost finished. Let's go ahead and FOIL this or distribute this 3 back through. Or actually, it doesn't really matter. I guess we could leave it in these simplified terms right here. Just leave it just like that. It's fine. We have nothing else we can factor on top. We have nothing else we can factor on bottom. There's nothing else that cancels from top to bottom. So I'm done right here. This is my answer. Moving on to the third example. I'm going to approach it the same way. I'm going to see if I can factor the top here. Well, that's just a constant, so that stays the same. My denominator in the first fraction, I can factor out a GCF. I can factor out an x, and when I do that, I'll get x minus 1. That's factoring this x squared minus x, taking out the GCF of x minus 1. Divided by, up here I can take out a GCF, I can take out a 2. So when I divide this by 2, I get 2x minus 1. And on the bottom here, I get, this is difference of squares, so I have x plus 1 and x minus 1, because 1 is a perfect square as well. So it doesn't look like anything cancels from top to bottom here. Nothing cancels from top to bottom here. And as I'm looking so far, I'm dividing. When I'm dividing fractions, my rule is keep switch flip. Keep switch flip, which stands for you keep the first fraction as it is. You switch the sign from division to multiplication, and you flip the last fraction. Now I can look to see if I have cross products again, and I do. On the bottom of the first fraction, I have an x minus 1. On the top of the second, I have an x minus 1. Those cancel. On the top of my first fraction, I have a 12, and on bottom of my second fraction, I have a 2 out here by itself. They have a common factor of 2. 2 goes into 2 one time, so that cancels into 1, and this cancels to 6, or reduces to 6. Because 12 and 2 were both divisible by 2, and I can reduce them by that factor of 2. Now multiply top times top, so I have 6 times x plus 1, which is 6 times x plus 1. And I have x times 1, which is x. Can't factor any further. Nothing else cancels. Done right there. Make sure, like what I just did, I left out this 2x minus 1. Can't forget that. You have x times 1 is x, and then the 2x minus 1 as well. But still nothing else cancels. I'm done right here. Don't leave out anything like I just did. Okay, and number 4 is for pre-AP only. So I'm going to see what factors here on the first top. What I might want to do to make this a little bit easier to see is I might want to rewrite it. I have x squared plus 7x plus 12 over x squared minus 7x plus 12 And this is, all fractions are division, but I might want to separate this into this fraction divided by this fraction and make it look like this. Divided by x squared plus x minus 12 over x squared minus x minus 12. And now I'm back to a problem that I had from above. See if I can factor. So on this top one right here, my signs are the same. They're both going to be positive. Two numbers that add to 7 and multiply to, that add to 7 and multiply to get me 12. The factors of 7 are 7 and 1 only, and there's no way that that's going to multiply to 12, so this looks like it's going to be prime, unfactorable here. I am off a little bit. This one is factorable because you have 4 plus 3 is 7 and 4 times 3 is 12. So the top would be x plus 4 and x plus 3. And then I have the bottom here, my signs would be the same. And I need to add, they're both going to be negatives here. So I'm adding to negative 7 and multiplying to positive 12. So that's going to be x minus 4 and x minus 3. And if you're struggling with what I'm doing by factoring here without actually showing my work, just take your time and go back and Mustang factor it, and you'll get these same answers here. Divided by this top one here, my signs are going to be different, and I need to add to positive 1 and multiply to a negative 12. So I'm going to have an x plus 4 and an x minus 3, because 4 plus negative 3 gives me positive 1, and 4 times negative 3 gives me negative 12. And on the bottom here, I need to add to negative 1, but still multiply to negative 12, so I'd have an x minus 4 and an x plus 3, because negative 4 plus 3 gives me negative 1, and negative 4 times 3 gives me negative 12. And again, if you couldn't do that factoring without working it out, take your time and work it out. I'm not saying you have to do it this way. So continuing on, what I would need to do is keep switch flip, because I'm dividing. So the first thing I have to do is the keep switch flip. So I'm going to keep the first fraction. And I'm going to switch my sign to multiplication, and I'm going to flip my last fraction. So the bottom becomes my top, and the top becomes my bottom. And so I look at my cross products. On the top over here I have an x plus 4, on the bottom I have an x plus 4, so those cancel. On the bottom over here I have an x minus 4, and on top over here I have an x minus 4, so that cancels. And so now what I'm left with is multiplying top times top and bottom times bottom. So I have x plus 3 times x plus 3, which is x plus 3 squared, over x minus 3 times x minus 3, which is x minus 3 squared. And I'm done. Nothing else to be done, nothing else factors, nothing canceled from top to bottom. I'm finished right there. So the name of the game for multiplying, dividing, or just simplifying these types of rational expressions is factoring. Maybe you can cancel from top to bottom, or maybe you can have cross products that cancel.